Okay, so again, we have our non-homogeneous equation. The y's are all column vectors, so is the g of t. This, of course, represents some number of equations. Okay, some number of linear equations, okay? A system linear equation. And your psi is your solution of the homogeneous system. Psi is a matrix that consists of the columns that are equal to your vectors in the fundamental set. So psi prime is a solution, or psi is a solution to the homogeneous equation. So psi prime equals p of t psi. This is a matrix product. And of course it's just a simple derivative.
So any solution to this equation will be a matrix, an n by n matrix?
Well, any solution to this equation is a column vector. But if you collect all the column vectors in their fundamental set into a matrix, that matrix is going to be a solution to the system. Okay, that matrix can be substituted for your y, for the homogeneous equation, leaving off the g of t. Okay? Now, variation of parameters, which is very simple in this case, very simple to derive if you just start with the premise that you have a solution psi of t, u of t equals your particular solution. Okay? So if you have this, well, you want to plug this into here. Well, derivative of this is just psi prime u plus psi times u prime, right? So yp prime, psi prime u plus psi u prime, just the product rule that applies to matrices, matrix functions, okay? And we plug it in, so the left-hand side is y prime, which is just this, and the right-hand side is p of t times this, okay, the yp, that's your y, and then your g of t. Okay, well, that doesn't look too bad, but you know, what are you going to do with it? Well, what you're going to do with it is you're going to, as we did with reduction of order in the original variation of parameters derivation for this higher order linear equations, we look for stuff that'll go away due to the fact that this is a solution to the homogeneous equation. Okay, so you look for the homogeneous equation down here somewhere. Okay? Well, you're going to have a psi prime. The only psi prime you've got is here, right? Of course, it's in front of u. But now you look for a p of t psi. Well, there it is, p of t psi, and it's times u. Meaning that since psi prime equals p of t psi, psi prime u had better equal p of t psi u. So you just subtract it from both sides, right? And you're left with psi u prime equals g of t. It's a matrix equation. You want to solve for u prime. And that should be familiar because what you get when you do variation of parameters in the previous case is you find u prime and you're going to have to integrate. And of course you can't always do that. I mean, you can always write the integral. Can you always figure out what the antiderivative is? Not necessarily. Okay? Okay, so anyhow, you got psi u prime equals g of t. How do you solve it? How do you solve a matrix equation? You multiply by the inverse matrix. Do we have an inverse matrix for psi? Yeah, because you have a fundamental set. And one test for whether you have a fundamental set is if the matrix of those column vectors has a non-zero determinant. So we know that psi has a non-zero determinant. So U prime equals psi inverse times G of t. And now you just integrate. Just, integrate.
That doesn't make any sense.
Psi inverse G of t. Which is just a column vector which says give n functions, each of which are going to integrate.
So you integrate each element separately, right?
Yeah, the integral of a column vector, of a column of functions, is just a set of antiderivatives of those functions. And you need to go back and review the calculus of of matrix functions and vector functions.
Yeah.
But it's just straightforward. Every component has to act independently.
I didn't really know calculus when I took linear algebra, so I didn't put that together.
Well, but that's in your text, if you've noticed. Calculus of matrix functions and vector functions.
Okay.
You know, you could read it.
I am reproved.
And it's very, very straightforward. It's very simple. It's exactly what you would expect it to be, which is this.
Mm-hmm.
So each of which you're going to integrate. Hopefully. There's no guarantee that your G of t function is going to give you stuff that when multiplied by psi inverse you're going to be able to integrate. Okay?
Is a psi matrix going to be a matrix of functions?
Yeah. It's a matrix function. So it is a matrix of functions. That's what a matrix function is. Okay?
Okay.
And you want to get straight on that, but again, the algebra of it and the calculus of it is totally straightforward if you understand how matrices work, which you do, but you know, you want to make sure you make the connections, and of course there's a section in the book that addresses it.
That's my bridge design.